Hi students, this is a lecture on section 13.1, which is about the GCF. The GCF, also known as the greatest common factor, is the largest factor that is in common for multiple terms. And the main thing we're going to be learning about here is how to find the GCF, and then also how to factor it out. Because chapter 13 is all about factoring, and probably the most important thing to start off with is the GCF. Okay, so let's see an example. Example, factor out the GCF from each polynomial. Okay, factor out the GCF from each polynomial. And for problem number 1, our polynomial is pretty straightforward. It's just 7x plus 28. So here, because there's no variable in common, this one doesn't have a variable, we're not going to be able to factor out an x. However, these numbers do have factors in common. In particular, I can rewrite 28 as 7 times 4. So we have 7x plus 7 times 4. And then if I rewrite it in this way, it's easy to see what's in common. The largest thing that's in common here is 7. So we can actually factor out 7. And we say 7 is the GCF. Okay? And if you don't want to write it out this way, you don't have to. A lot of people can do these in their head, like I can do them in my head. I just think, well, what's the biggest number that goes into both 7 and 28? Well, I know 7 goes into 7, and 7 also goes into 28. So that's the biggest number that can go into both of them. And here, I have it written that way. Okay, so then once you have the GCF circle like this, you just go ahead and factor it out front. So I factor out what I circled, and then I put parentheses around whatever I didn't circle. So I'm going to have parentheses around x plus 4. So we have 7 times the quantity x plus 4. And that's actually the whole problem. So really just 2 steps. Okay? All right, and we're going to be doing lots of examples to make sure you're solid on these. So let's take a look at problem number 2. Problem number 2 is 24x minus 3. 24x minus 3. So here, once again, you want to think of the biggest number that goes into both 3 and 24. Well, 3 goes into 3. And 3 also goes into 24. So that means the GCF is 3. GCF is 3. So I can rewrite 24 as 3 times 8. So we have 3 times 8x minus 3. And for this second term, I can rewrite the minus 3 as minus 3 times 1. And we'll see why I wrote it as minus 3 times 1 in just a second. So now I circle the GCF, which is what's in common here. And whatever I circled, I factor it out front. So I bring the 3 out front, and then I put parentheses around whatever I didn't circle. So I'm going to have parentheses around 8x minus 1. And notice there's still a 1 left over, and that's why I wrote 3 times 1 here, to remind myself that even though I factored out the 3, there's still a term here, so there still has to be a negative 1 left over. Okay. And again, with this problem, we don't have a variable for both of the terms, so x is not part of the GCF. So this x just stayed here. But you will see problems where multiple terms have the same variable. And that's what we're going to see for the next problem. So for problem number 3, we have x to the 5th plus 15 x to the 4th. So for the x to the 5th, remember if they don't write the coefficient, it's automatically 1. So this is the same as 1x to the 5th. Well, the biggest number that goes into both 1 and 15 is just 1. But there's no point in factoring out a 1 because it's not going to do anything. So here, for our GCF, we're going to have to focus on the variables. So it turns out the GCF of powers is the smallest power in common. It's actually going to be the smallest power in common for all terms. So now what does that mean here? Like I said, for the numbers out front, for the constants, the 1 and the 15 don't really have any common factors, so we can't factor anything out for the constants or the coefficients. But for the powers, we can factor out the smallest power in common. So I know it sounds like greatest common factor would be the largest power, but it technically is the largest power, but it's also the smallest power that appears. Okay? Okay, so the GCF of powers is the smallest power that appears in every term. So it's a little bit strange how it works. But the reason I'm saying it that way is here you might think that you could pull out an x to the 5th because that's the largest power that appears. But it's actually, for powers, it's actually the smallest power that appears for every term. So that's actually going to be the x to the 4th. Okay, so here the GCF is x to the 4th because that's the smallest power. So then how do we factor out this GCF? Well, what most people would do is they would rewrite the first term as x to the 4th times x. Okay, so the first term is x to the 4th times x. Now remember that works because x to the 4th times x is the same as x to the 4 plus 1, which is x to the 5. So we have x to the 4th times x plus 15x to the 4th. And then we can see here that we have it factored. So I can go ahead and circle my GCF, which here is x to the 4th. So that's going to mean we can factor the x to the 4th out front. That's what we circled. And then we put parentheses around what we didn't circle. So we have parentheses around x plus 15. Okay, so our answer is x to the 4th times a quantity x plus 15. Okay? And some of them get a little bit more challenging, so I wanted to do some of the harder problems. Okay, so for number 4, for example number 4, this is going to be a challenging problem. For this one we have 3 terms, and this one is 15 x cubed y plus 5 x squared y minus 5xy. So this is tricky because there's 3 terms. But because there's 3 terms, we need to focus on each part separately. So let's start with these numbers. So let's start with these coefficients of each term. So looking at 15, 5, and 5, the biggest number that goes into 15, 5, and 5 is 5, right? Because 5 goes into 5, and 5 goes into 15. So for our GCF, we're going to have a 5, because that's the biggest constant that goes into all three of these. And then the next thing we look at is actually the x's. So remember, this x over here, where it doesn't have, when it doesn't have an exponent, the exponent is automatically 1. So all these ones that have an exponent, that don't have an exponent of 1. Okay? So so looking at the x's here, the smallest power that appears in every term is x to the 1. Okay, so in our GCF, we're actually going to have x, which is the same as x to the 1. And then looking at the y's, the smallest power that appears in every term is y to the 1, which is the same as y. So our GCF here is going to be 5xy. And so we want to factor out a 5xy. And if you want to make it a little bit easier when it's this complicated, what most people do is they write the 5xy out front, and then they put parentheses, and then they figure out what's left. Okay, so we're assuming we've factored out the GCF, which is 5xy, and then we need to figure out 5xy times what gives me this, 5xy times what gives me that, and 5xy times what gives me that. So let's start with the first term. 5 times 3 is 15. So that means we have a 3 here. X times x squared is x cubed. So here we have a 3x squared. Now how did I get x squared? Well, remember, if you have exponentials with the same base and you're multiplying them, you add the exponents. So this is x to the 1 plus 2 gives you x to the 3. Okay? And then obviously y times 1 gives me y. So that means we don't need a y for this first term, because we've already factored it out. So this first term should just be 3x squared, because 5xy times 3x squared gives us 15x cubed y. Okay, so we're done with that first term. Now we're going to take a look at the second term. So here, 5 times 1 gives me 5. Okay? X times x gives me x squared. Okay, so we're going to have an x here. And then y times 1 gives me y. So really all we have here is 1x, but you don't need to write the 1. Remember, instead of writing 1x, you're just supposed to write x. Okay, so it's going to be x is our second term. And then for our last term, 5 times negative 1 gives me negative 5. So for this last term, we're going to have a negative 1. X times negative 1 gives me negative x. Y times 1 gives me y. So here, all we really need is a negative 1, because 5xy times negative 1 gives me negative 5xy. And this is the standard way to do it if you're feeling lazy, because trying to rewrite these in a factored form before we do this can be a lot of work with a long problem like this. Okay, so this is going to be our answer. 5xy times a quantity, 3x squared plus x minus 1. And you can always check these by distributing the 5xy to each term. Okay? So that was a more challenging problem. And I wanted to do one more challenging problem for the GCF. Okay, so for problem number 5, we have r times a quantity, z to the 4th minus 17, plus the quantity z to the 4th minus 17. Okay, so r times a quantity z to the 4th minus 17 plus the quantity z to the fourth minus 17. So what's going on here is this one's a little bit tricky because you might not be sure what's in common here for our GCF. Well, remember, the GCF is the biggest thing that's in common. Well, the biggest thing that's in common here actually has two terms. So here we can see the GCF appears in both terms. So it's z to the fourth minus 17 is actually the GCF here, because that's what's in common. Okay, so our GCF is z to the fourth minus 17. It's okay that it has more than one term. As long as it's in common, you're still allowed to factor it out. Now, the only thing that's tricky here is for this second term, we are going to factor out the z to the fourth minus 17, but for the second term, what's left over is still a 1. So there's still a 1 left over here. Okay? So now we're ready to go ahead and factor out the GCF. So I factor out what I circled. So I'm factoring out z to the fourth minus 17. And then whatever I didn't circle is what's left. So inside the parentheses, I have r plus 1. And notice it was important that I left a 1 there because there was actually a second term here. Okay? So it's z to the fourth minus 17 times a quantity r plus 1. And it looks like you might be able to factor it more, but this one you can't actually factor more. So that's your answer. Okay, and that's about as hard as this type of problem gets in your homework.